What's going on, PlayDate Community? Welcome back to another episode. My name is Franchovy and I am building your game in this PlayDate tutorial. We're on episode 10, so we're gonna have the first playable version of this game by the end of today. We'll still have some things to do, but let's get right into it because it's an exciting one. Last time we added this little gas type enemy. For now, he doesn't do anything, he's just chilling, sleeping. We're gonna get him to chase the player, and he's gonna chase the player slowly so that we can potentially do more stuff with there. I went ahead and asked the community whether these gas should shoot or chase the player, and what I got as a response, I liked. There we go, you can see it on screen. So for now, we're gonna do the chasing action because that's way simpler, and then we're gonna go for the shooting action down the line. But anyways, it's gonna be very similar. Also, quick tip guys, if you don't have this add-on for VS Code, I really highly recommend it. It's called Git Branch, it's called Git Graph. And it's super useful if you're gonna start doing more complicated Git stuff. It also lets you do the actions. And so here you can see that I'm managing this project and every project I do using this plugin. So highly recommend it. Let's get right into it, guys. So first thing that we want to do is that we want the enemy to chase the player. How are we going to do that? So we're in the enemy class. We want to know where the player is, first of all. And then we want to calculate how to get to the player, and we're going to move towards the player. So first thing we need to do is actually get the location of the player. So we're going to add a comment right here. Get the player, and then calculate path to player. It's not a path. I'll simplify these comments. But anyways, the way we're going to do this is that we're going to say, I'm going to say inside the init call, right after the super, so on line 12, I'm going to say player.instance equals self. So what I'm doing here is that I'm actually setting the reference to the instance when the instance is being created, and I'm setting it on the class. If that doesn't make any sense to you guys, don't worry, just write that line. When we get to the enemy, we're actually going to say, now we're in enemy.update, I'm going to say player, capital P, dot instance, that's the end of the line. I'm going to say local player equals player.instance. So the first player is lowercase p, and then when you're getting the instance, that's the class. So it's going to be capital P. Then we're going to do just a security check. We're going to do if player then. So in case, we create an enemy before we create the player, for example, we want to make sure we don't mess anything up. Then we would be calculating the path to player in there. So I'm going to do this really simply. I'm going to say local target x, comma, target y equals player.x, comma, player.y. So that's going to be the target of where we want this enemy to be. And then I'm going to say, next comment, move to player. I'm going to say self colon, move to target x, target y. So just to test it out, let's see if this is working. I'm going to hit refresh right here, and you can see that this gas is really sticking to me. So everything's working as expected. Let's get this gas to move in a constant speed in the direction of the player. So first of all, I'm going to define at the top, above the class in the enemy file, I'm going to say local speed. And I can make this a const. Maybe we want to change that later. And I'm just going to say 1 because we want it to be relatively slow. So it's basically going to be 1 pixel per frame. So 30 pixels per second. Yeah, if you guys are used to miles or kilometers, we're talking pixels now, and per frame and not per second. So from here, what we're going to do, so if we actually use this target X and target Y, we don't have a way of converting that into a speed without first getting the angle. So I want to show you guys really quickly. This is also your second best friend. The math library in Lua is super useful. It has a bunch of stuff that's great. So we've got like trigonometry functions. We're going to come back because we're going to use random. Right now we're going to use arc tangent. And as you guys know, I am an expert in trigonometry. I'm actually the reincarnation of Leonardo da Vinci, who was the inventor of trigonometry, as you all know. And so me and my math brain, and definitely not the AI search I just did, figured out how to do this using the A10 function. I'm going to show you guys how to do that. It's really, really complex things. So we're going to say local angle equals math.atan, and you can see it says y and then x. So we're going to do target y minus self.y, so this is the enemy self, comma, target x minus self.x. And so that will give us the angle. And if you're not convinced, then just look at Stack Overflow, because somebody had exactly this problem and solved it for me. Yeah. Now we're actually gonna use the same function as we did before in the player when we were shooting the bullet. We're gonna get the x and y using the angle and a speed. Issue is this function right now is inside the player class. So I'm gonna show you guys how to make a utilities folder. We're gonna click on source, right click on source and hit new folder. We're gonna call it utils. And then we're also gonna create a file in source called utils.lua. And then inside utils folder, we're gonna say new file, and we're gonna say angle.lua. And what we can do is that we can copy and paste that function from the player class into angle. And just remember to remove local, or else this function is not going to be accessible in other files in the game. So now we've got our utils. We need to, in utils.lua, we need to do import angle.lua. By the way, this is a very, very standardized thing that I do, like the file system. So there's infinite ways of doing this, but the way that I do it here is really straightforward and simple and standardized. So if you want to follow it, you can follow it. If you don't want to follow it, do what you like, but I'm telling you, this is the easiest way. Okay, and then from main.lua, we say import, in quotes, utils. Utils.lua, you have to say import, open quotes, utils/angle. So you're getting it from that folder. Back to enemy, back to the update function. We're going to say local x, comma, y equals get rotation components, which is the function that we just exposed. And we're going to say, so rotation in radians, we're going to say angle. And then velocity, we're going to say speed. How easy is that? And then it's not going to be moved to, but it's going to be moved by x, comma, y. So let's refresh the game. And you can see that it's working. We've got this little gas that's chasing us around. All right, that's awesome. Let's turn around and go. Ooh, you dead, brother. Let's add a spawner that'll create new enemies. I'm gonna create a spawner inside the utils. So I'm gonna do utils, new file, and I'm gonna call it spawner. Spoiler alert, spawner.lua. And so I'm going to use a class for this. So I'm going to say class, in open brackets, in quotes, spawner, and then skip to the end. And you're going to hit dot extends, and you're going to open and close brackets with nothing inside. So usually we would use this to inherit the sprite functionality, and you can actually inherit the functionality from whatever you want using this class syntax. Here we're actually just going to create a class that we can create instances for, but we're not going to give it any parent class. So we're just going to create a class here by itself. We're going to say function spawner colon init, open close brackets, and skip, go ahead and type an end there. And we're going to define multiple things. So when you create a spawner, you need multiple things. What are you going to create that spawner for? So we need a sprite. We're actually going to take in the sprite class. So we're going to call that sprite class. And maybe we want a spawn rate. So how often do you want that thing to spawn? So I'm going to call it spawn rate. And yeah, so we're ready to go. We're going to say self.sprite class equals sprite class. And then self.spawn rate equals spawn rate. Okay, I'm just gonna do self dot is active equals false. So by default, the spawner is gonna be turned off. I'm gonna create two functions, really easy. Function spawner colon start, open close brackets. And inside start, I'm gonna say self dot is active equals true, end. And then function spawner colon stop, self dot is active equals false. And then type in end. And then now we're gonna have this, the juicy function, the stuff that actually does the work. It's gonna be the update function. So we're gonna say function spawner colon update, open close brackets. And so in here, what we're gonna do is that we're gonna use the spawn rate to check whether we should spawn a sprite or not in this tick. So in this execution of the update function, and using the spawn rate, we're gonna say, do I have to spawn something or do I not have to spawn something? If I do have to spawn something, then I will create an instance of that sprite class. Let's get to it. So first comment, check if sprite should be spawned. And then second comment, spawn sprite, and then end. And actually we're missing one thing. If the spawner is not active, so this is we're gonna write a comment at the top of the update function. If spawner is not active, return. So let's type it out. Let's type out the code. If self.isActive, then so it's the other way around. If not self.isActive, then return. So this is our guard statement. It's kicking us out of that function in case the spawner is not active. Then we need to check whether the sprite should be spawned. So this spawn rate is actually going to be in percentage of whether a sprite should be spawned in a given tick. So we can say spawn rate per tick. We can actually, if you guys want, if you want to keep it simple, you can keep spawn rate. But I'm going to say for extra clarity, self.spawn rate per tick, and change the arguments in the init class as well. And so I'm going to say like this: if self.spawn rate per tick, we're going to use math.random right here. So you see that math.random with no arguments generates a real number between 0 and 1. And we expect this spawn rate per tick to be a percentage, so between 0 and 1. So what we're going to do is, if math.random, open close brackets, is less than self.spawn rate per tick, then basically spawn the sprite. So you can move that comment into that if statement. How do you spawn a sprite? Well, good news, we have the sprite class. So we can actually spawn the sprite right there and then. So we're going to say self.sprite class, open close brackets. This is going to create your class. So imagine it, Lua's a crazy language. You can do all sorts of stuff with it. What you're doing here, let's say when I create my spawner, I pass in enemy. What you're doing here is that you're calling enemy open close brackets. But the thing is that it's under a hidden layer where you have sprite class being passed into it. So when we're creating this spawner, we're actually gonna pass in enemy to this sprite class, then it gets assigned to the self, and then now we're using that self. So we're creating an enemy. So local sprite equals self.sprite class. That's the line, open close brackets. And here we're just gonna put this enemy on screen, or we're gonna put the sprite on screen. So comment, put sprite on screen. So I'm gonna say sprite colon move to, and then I'm gonna calculate an x and a y. So I'm gonna say math.random, again, favorite function, 0, 400 for the x, and then math.random, and I'm going to say 0, 240 for the y. So those are the screen coordinates. And so it's an entire range of the screen. And then I'm going to say sprite colon add. And I think that's it. I think that's everything that we need for that. So now that we have our spawner, first of all, we need to add the import to the utils function. So we're utils file. So go to utils.lua and add in import colon import open quotes utils /spawner, And now we can use it in our main.lua. So instantiate classes right here. I'm going to say local enemy spawner equals spawner, open brackets. And now this is the moment, guys. I'm going to type in enemy with a capital E. And then the spawn rate, I'm going to do this in a clean way. I'm going to say enemy with capital E dot spawn rate. Crazy, right? And I'm going to say spawn rate per tick, just because I want to be extra clean. So that requires us to go back to the enemy.lua. Underneath class enemy, we're going to say enemy with a capital E as usual, dot spawn rate per tick equals, and this is where you're going to put the spawn rate per tick. So I'm going to say 0.01. So it's going to be basically 1% chance every tick for an enemy to spawn. So back to main.lua, we've got this enemy spawner. We're going to start it in the init function. So we're going to say enemy spawner colon start, open close brackets inside the init function. Then we're going to say inside playdate.update, we're going to say enemy spawner colon update, open close brackets. So this is going to update the spawner every tick so that it's able to spawn in the enemies. So I think we're ready to run this. Are you guys ready? Let's go. Restart. And we did it, guys! We spawned them! Awesome. Wow, that was suspenseful. I wasn't sure it was going to work there. I think the spawn rate is... okay, never mind. They're coming. So now you can see that we've got our spaceship, and we can turn around and shoot these little guys. I'm gonna use Buggy over here to enjoy some of this gameplay. So you can see that the bullets are despawning really early, which is probably something we want to be able to fix. So hold on, I'm gonna update the bullet so that it lasts a bit longer. So here we've got bullet.lua, and we're looking at bullet.spawn, and I'm gonna say when we're creating the destroy timer at the bottom, I'm gonna say here 4 seconds, so 4,000. Just for reference, I think we only have 10 bullets in the sprite list, so go to the top of the page, and I think we can increase this to like 25, because I know that 10 is not gonna be enough. So let's restart, and we've basically got our monsters that are spawning, and then we can shoot the bullets. That feels a lot better for sure. I don't see bullets randomly disappearing. Thanks so much for watching, guys, and please, more suggestions. I'm ready to start putting in some fun stuff like, obviously a live game over screen that's probably gonna be up next, and maybe like a shop, different abilities, the monsters shooting at you. I saw that there's different ways that we can go, like a twin stick shooter could be one way, so moving around with a keypad, D-pad I should say, or we could do like a vampire slayer type thing where the ship itself can shoot enemies without you having to press A and face them. But anyways, I hope you're enjoying the series, guys. Leave your suggestions in the comments, and I will see you in the next one. Bye bye.